Hello?
I don't have any questions at this time.
I don't have any question, Professor.
Okay, you don't have any special questions?
Only thing I have to say, the homework last week,
Yes.
it tell you to draw a line, but I don't know to draw the line, so I make dots go across.
Okay, so I'm going to go to the homework last week and see what line is supposed to draw. I think,
Okay.
I mean, like it says to draw a graph.
Yes, yes.
Okay, so let's see what it is like.
Okay.
Okay. All right, so I'm going to pull up the assignment, okay? So let's give me a minute. Okay, so this is what you're talking about. Hello? Can you hear me?
Yes, that's the homework, yes.
Okay, so you're looking at using the findings in Part B, draw the security market line.
Yes, yes.
Okay. Now, what you need to do then is to ask yourself if the free rate of return, excuse me, okay, is the risk-free rate is 3%, the market rate is 10%. I'm going to solve for the rate of return for this. And so what you need to do then is to ask yourself, you know, the security market line is such that you solve the equation and draw a graph, okay? Let's see if we can draw that graph, okay? Just give me a minute. All right, so essentially what you have to do here is to ask yourself, what if you change the market rate of return, okay? So I'm going to okay, so we don't have to now what you have here is and I'm going to change this. I'm going to move this over here and see if we have the same results. Then I will explain to you what we're doing. All right, so now remember that we had the formula, right? That the return on asset is equal to the risk-free rate plus the beta times Km minus Kf. Do you remember that formula? Hello? Hello?
Yes, I remember. Yeah, yes, I remember the formula. That was for last week.
was for last week. So you solve the equation, right? You solve the equation for that particular asset, okay? And you ask yourself, what if the market rate changes, okay? What if the market rate changes? What will be the return on this asset? All right. And so essentially, here we say the market return is 10%. And so the risk-free rate we know is 3%. We ask ourselves, what would be the return for this asset? The return for the asset will be the 3% plus the market rate minus the risk-free rate, right? Which is in here, we're using Excel. And so here we're using H11, which is the risk-free rate here, KM, okay? And the risk-free rate here is 12%, there's 14%, there's 16%. I mean, you can change this to 11%, change this to 12%. Let me make sure we don't create problems here. Okay. And you can just go on and make this as long as possible. Okay, so we're changing the market rate. And so now I'm going to solve this for other problems now. So that's just to make a point. And so once you are done, you make a graph, you paint, you insert, and you use the scatter diagram, okay, and take a line. And so you can see what the graph looks like. So this is essentially what you're supposed to do. And so you draw the security market line. Now, what if we were looking at the other assets? Okay, what if we were looking at the other assets? And so the asset with a beta, let me check. Okay, there's an asset with a beta of 0.75. Okay, a beta of 0.75. And so we can also plot that one. Okay, I'm going to call that K2. And you can also get the risk-free rate for that. Okay, I mean, you can also get a line for that. For example, I will put this over here. This is the beta for this one will be 0.75 times H11 minus 3. So in this case, this asset will have lower returns. And you can plot a graph with that, and you get the same security market line, except that the location of the lines will be different. You insert, go to the charts here, and choose the scatter with a straight line, and you get another security market line. That is, you're going to keep getting the security market lines, with any one of them. All you have to do is to change the market rate of return. Okay. So that's essentially what you were supposed to do, and nothing more than that. And I'm going to solve that problem and post it for the class so that we're able to prepare for the final exam. I need to remind myself of that. If I don't, please remind me to solve that problem and post the results for the class. Okay, does anybody else have any other question? Okay, so today what I'm going to do is I'm going to try to prepare your mind for the assignment that is due next, which is on capital budgets. So we're going to talk about capital budget, and I'm going to pull up PowerPoint slides on capital budgets, okay? And so at least we understand what capital budget is, and then the decision criteria. So today, we're going to focus on very simple decision processes for capital budgets. Then from next week, we'll get into cash flow calculations, and we get into other kinds of more complex analysis of capital budgets. So let me be sure what I'm going to pull up, and then I'm going to pull it up. All right, I'm going to share screen. All right, so I'm going to talk about capital budgeting and very, very quickly, okay? When you talk about capital budget, what do you mean? Okay, capital budgeting is a pretty simple process or concept to understand. And capital budgeting methods can be used by you as an individual person, or by a nonprofit institution, can be used by businesses, small or big. When, for example, you say, how do you do, how can an individual do a capital budget? How can it apply to a person, just you? Capital budgeting is used to allocate long-term investments. When you buy a car, or when you buy a house, you are making a long-term investment. And so think about, for example, when you buy a car that is 9 years old, and then you have to go and repair it every now and then, you ask yourself, how much money do I spend every year fixing this car? And what would be the benefit to me of buying a new car and having to put out so much money to buy the car? What am I going to save? How is it going to be better for me? So that kind of decision about whether to buy a new car or to continue to fix the old one is a capital budget decision. Now, going back to businesses, businesses do capital budgeting for different reasons, okay? It could be to replace an old equipment that is costing so much money to fix. It could be to explore new markets. And so is it worth it to invest in a capital equipment or a building in order to explore this new market or to break into this new market? It might just be to refinance a loan that is, the interest rate is much lower. Now you borrow money to refinance the loan. Now, but think about the fact that when businesses go to borrow money, there's a cost to it. Okay, there's an upfront fee, legal fees, meetings, what have you, that are involved in trying to get a loan. And so you ask yourself, if you have to incur all this expense to refinance this loan at a lower rate of interest, are you going to save money enough to justify the expenditure? Okay, and there's so many other reasons why a business would engage in capital budgeting and having to make capital budget decisions. So our purpose here then will be to learn how to evaluate capital budget propositions, okay? Now, the basic principle for the evaluation of capital budget is based on the time value of money that we already learned about, which is to say, you invest money today and you expect the investment today to yield cash flows into the future. And as you know, money received in the future has less value than money received today. And so the whole idea then would be, if you make an investment today to buy a new piece of equipment, to buy a new building, to refinance a loan, or whatever reason, will the investment return enough to justify the expenditure? All right, so here's an example, like Disney's decision to invest $17.5 million to build a new park is a capital budgeting decision, okay? Okay, so I mean, there are steps in the process. First of all, you identify the promising investment opportunity, and that promising investment opportunity could be a new product that you want to launch. It could be a new market that you want to get into. All right, those are two good examples. It could be to replace an equipment that is already old. It could actually even be to make a choice between two different options of equipment or building or what have you. All right. These are examples, revenue enhancing investments like a new market, cost reduction investments like maintaining some old equipment, cost savings for a new technology, a new method, okay? And so the methods that we're going to use and the methods we're going to explore today, we're going to explore two methods, very quickly. One is the net present value criterion, and the other is the IRR, the internal rate of return, okay? The profitability index is very easy. We'll get into the EAC much later when we are dealing with a slightly more complex investment decision, and then we will learn about the EAC and apply it all at the same time. Okay, so the net present value method is pretty simple. You invest $1 million today, you invest $500,000, $200,000 today, and then you ask yourself, what is the cash flow in the future? And so the factors that you take into consideration are the amount of investment today, and then the cash flow for every period for 3 years, 4 years, 5, 6, 7, 8, 9, 10, 20 years, whatever the life of the investment, okay? If you buy a piece of equipment, you ask yourself, is this piece of equipment going to last 6 years or 7 years? So in those 6 or 7 years, what will be the cash flow each year, okay? Then the other factor that you have to take into consideration is your cost of capital, okay? For now, let us just, take the simple concept, cost of capital. That's the cost of obtaining funds. And so in the next couple of lectures, we will then think about how to define the cost of capital or how to calculate the cost of capital and still use that cost of capital to make investment decisions. All right. So the method we're going to use, we're going to learn about first, is the net present value method. Okay. The net present value method is the difference between the present value of cash inflows and cash outflows. Very simple. Okay. If the net present value of an investment is greater than 0, okay, if the net present value is positive, then we invest in the asset. If the net present value is negative, then we do not invest. So I'm going to, this is the formula for net present value, okay? Is the sum of the discounted cash flows. Let me see if I can, okay. Let me say the sum of discounted cash flows. Okay. And so discounted cash flow is the cash flow for each period divided by 1 plus the cost of capital. So K is the cost of capital, CF is the cash flow. And so we add all of this together. Let me see if I can bring that. All right. So here is a way you write out the formula. Cash flow for the first period divided by 1 plus K to the power 1. And then for the second period, divided by 1 plus K to the power 2. And you go on and on until you get to the last cash flow, which is what we have here. So this is the sum of discounted cash flows. And the discount is simply the cash flow divided by 1 plus K to the power T, where T is the time period, okay? So the money you're gonna receive the first year, you discount by 1. The money that you're gonna receive the second year, you discount to the power 2. And the money that you're gonna receive in the 8th year, you discount to the power 8 for the 6th year, and so forth and so on. And so, like you see here, we go from 1 to 2 to 3 to 4 to 5 to 6 to 7 and to 8. All right. So I'm going to see if I can pull up an example. This is the same problem that we did here. And you can see the net present value is 28, which is positive. And so we accept the project. And so somebody's going to ask me, well, how do you implement this? And I'm going to try to implement a problem here for you. And so maybe that could help. Just give me 1 second. I'm going to stop share for a minute. And then I'm going to pull up another file. All right. Are you seeing my file? Are you seeing the new spreadsheet?
Yes, Professor.
All right. So let us say that we invest $250,000. As you can see, that's a negative amount. That's a cash outflow. all right? We invest $250,000. And so this is year zero, which is the beginning of the investment, or time period zero, which is the beginning of the investment, okay? And so this project is going to be a 10-year project. So you invest in a piece of equipment that is 10 years, okay? It's gonna have a life of 10 years, and after that, you have to discard the equipment. Now, let us say that the cost of capital is equal to 10%, okay? Which is 0.10. Let us say your cost of capital is 10%. So now the question becomes, is this investment worth it? The investment will yield you cash flows of 60,000, 61,000, 63, 64, 67, 68, 69, 70, and 72. So these are the anticipated cash flows for those 10 years. So if the cost of capital is 10%, is this investment worth it? So this is the cash flow, the discounted cash flow. We're going to call it DCF for the time period, for each time period T. Okay, and the T will be from 0 to 10. Okay, so these are the discounted cash flows for each of those periods. And so we're going to use Excel to solve this according to the formula that I showed you earlier. Okay, so we divide 250,000 by 1 plus k, that is 1 plus 0.10 to the power 0. And here we're going to divide it to the power 1. And so this will be equal, okay, F6. You can see, so we're going to divide that by 1 plus 0.10 to the power E6, okay. Okay. So we divide the cash flow for the period by 1.1 to the power of the time period. So once we do this on a spreadsheet, that's easy. And we drag it down. All right. And so the net present value will be the sum of all the positive cash flows minus the investment. Okay, so we can sum all of that. All right. So you can see from this problem that the net present value is positive. Okay, the net present value is positive. So for that reason, we will accept this investment. Okay, we'll accept this investment. Okay, so let's stop this and then go to the next topic. All right, so I'm going to share screen again. All right. So, because we've already discussed this, once you pick an asset, you identify a potential opportunity, you decide on a solution strategy. What method are you going to use to evaluate investment? Is it going to be net present value? Is it going to be IRR? So we have already done that. We have decided for that asset, we're going to use the net present value because we calculate the NPV and accept the project if NPV is positive and reject if negative. Okay. And so when you have alternative investment projects and you are facing financial constraints in the sense that you have 10 projects that have, some of them have negative net present values. So you reject those ones outright. So you have 6 out of the 10 projects that have positive net present values. And so which ones do you choose? Well, generally, businesses are constrained in terms of how much capital they have access to. And so what do? Of course, you choose, suppose that you have enough money to do only 4 of those 6 good projects. So you choose only 4, okay? If you have enough money to choose to do only 3 of them, then you do 3 or 2. If you have enough money to do all 6 of them, it's fine and good. You can do all 6 of them. All right. So, like I said, I'm going to do the EAC some other time. Let's now solve through other investment criteria. The PI index is very easy. For example, for the problem that we had, the PI index will be NPV over investment. That's very easy. And in that particular problem, what did we have? The PI would have been let me see, not the NPV. Okay. So let me stop share this. Okay. Now, for example, the PI will be equal to the PV of cash flows over the investment, not the NPV, the PV of the cash flows. And so in that case, the PV of the cash flows will be all the positive cash flows for the future. And then you divide this by that. And so essentially what I have done is to take the sum of the positive cash flows, which is these cash flows, and that gives you 360,000. And so the PV will be the PI will be this divided by that. That is to say, the sum of the positive cash flows over the investment. And so what we're going to have is H16 divided by G6. okay, which is 1.44. Of course, and if the PI is greater than 1, you accept the project. If the PI is less than 1, you don't take the project. Well, the MPV, if the MPV is positive, then the PI will always be greater than 1. So this is why I don't spend my time talking about it. That's very easy to do. Okay, this is not MPV, this is the PV of cash flows. Okay, that is the PV of all cash flows divided by the investment. And so in that case, we would have had the numbers. $360,000 over $250,000. Of course, we find to be 1.44. So in that case, the PI is greater than 1. Okay. All right. So the next thing that we're going to try to do, this is another example of a problem. So we're not going to go through that again. That is the same thing we've been doing. All right. So the next thing we're going to talk about is the IRR. Okay. The IRR, I'm going to label this IRR. Okay. Now, the IRR in every sense is a mirror image of the NPV. That's what I call it. I call it a mirror image. But the asking about the IRR, this gives you an idea of the relative magnitude of the rate of return. Okay, in a sense, what is the rate of profit in this project compared to the cost of capital? Okay, what is the internal rate of return? Because when you calculate NPV, essentially tells you the cash, the cash difference between the investment and the cash flows. The IRR, the internal rate of return, essentially says we are obtaining capital at 7%. What is our own rate of return? So this business, this investment is going to yield 15%. Oh, so that's a good idea. If our rate of return is, if our cost of capital is 6%, and this venture is going to yield a return of 9%, then it's good. If going to yield a return less than our cost of capital, then it's no good. And so how do you calculate the IRR? Okay, and I'm going to give you an idea. And so let's take a project. And I'm going to pull up a project right now. Okay. All right. Now, the same project, okay, the same project, when you look at it, you see we had an investment of $250,000, okay? And investment is going to yield these cash flows. The cash flows we already know about, all right? Okay, the cash flows we already know about, and let's see. All right, so let's see how we're going to solve this problem. I'm going to sort of slightly modify this. All right. All right. So we're trying to find out what is the IRR of this project. Okay. And the way to find IRR, essentially what IRR says is what would be your cost of capital such that the NPV of the project is zero? What cost of capital will make your project NPV to become zero? Okay. And that cost of capital is what you call your IRR. Okay. So, and the way to simply do it is you take these are the cash flows for each year. And so you take different possible cost of capital. And these different possible costs of capital, then you can plot them on a chart. Okay. And I'm going to plot them on a chart. And when you plot them on a chart, you calculate, okay, you take all possible different costs of capital, and then you calculate the NPV for each of them. You can see if your cost of capital is 5%, what will be the NPV? And the NPV is what you have below here. Okay, NPV is what you have below here. And as you can see, by the time you go from 15% to 17%, your NPV goes from positive to negative. And so, in fact, we could actually let us say we have like this is 9, 5, 7. Okay, so we take 2 percentage points. But what if we were to take like 6%, 7%, 8%, 9, 10, 11, 12, 15. Okay. Let's go. Okay. All right. Then I just made the problem simple. And so by the time you go from 16% to 17%, you can see that your NPV goes from positive to negative. And so your IRR is somewhere between 16 and 70%. And the best way to resolve the exact amount is to plot a chart. Okay. Let me see if I can plot a chart. Okay. Going to put the NPV here. See. Okay, there. See if I can plot a chart. Okay. 05, 06. All right. And so this is the cash flow. Let's see if we can get something out of this. There we go. We'll move the chart. All right, so you can see that your MPV is somewhere there between 16 and 17%. Okay, your IRR, not your MPV. So when you plot the chart, you can see that as your rate of interest goes up, as your cost of capital goes up, then your MPV is declining. Okay, until you get where it crosses the 0.0, and so that is your IRR. Okay, that's your IRR. So that's how you actually determine IRR using a graph. Otherwise, you can go through a mathematical process, which is very tedious, by trial and error, to get exactly what it is between 16 and 17%. You can do that. Now that you have an idea, you can try 16.1%, you can try 16.2%, but we really don't need to do that here. All right. So this is essentially what we need to do. So I'm going to stop the lecture here and ask, does anybody have any questions? Hello?
No, Professor, so far, no.
Okay.
Yeah, very thorough, Professor. No question.
All right, so I hope you're going to be able to solve your homework assignment. You have 2 problems. If you still have any questions, give me send me an email. All right, and I will try to help you with that. So on that note, have you a nice evening and enjoy yourselves.
Right, Professor.
All right, good night.